Okay, here's warm up 12.5. So this first problem, we've got two different groups here, left-handed students and blue-eyed students, and there's going to be some overlap between those. So there's going to be students who are left-handed who also have blue eyes. So this is a situation where a Venn diagram like this might be helpful to organize the information. Okay, so let's start breaking this down. Out of 120 students surveyed, so my total here is 120 people. I'm just putting that up there so I remember. Okay, and then we've got 20 are left-handed, so I'm going to put 20 right there for my left-handed students, and it says 58 have blue eyes. Okay. Now, it says 2/5 of the left-handers have blue eyes. So that's going to give us this crossover category here, right? It's 2/5 of the left-handers are in that group. So this would be 2/5 of those 20 left-handed students. Okay? So if you multiply that together, that would give us 40 over 5, which is going to be 8. So that means there's 8 people in that crossover group. Okay? Now that we've got this 8 right here, we can use that to figure out how many people are in this section. So we know there's 20 total left-handed people. 8 of them are in that section. So 8 plus something is 20. That's got to be 12, right? So this is 12 right here. We can use the same logic over here. 8 plus something is 58. That means this would have to be 50. Okay? Now there's one more group I have to figure out, and that's the people that don't have blue eyes and they're not left-handed. So that's my neither category. That's what I'm going to call that, and neither of those groups that I have identified there. So the way I'm going to figure this out, I'm going to take the 120 total people, and then I'm going to subtract out the people in these groups. And it's tempting to think, oh, there's 78 people in those groups, in these two groups. But there's actually not 78 people, because there's some people who are in both categories. So if I just take the left-handed people plus the blue-eyed people, that's 78, but then I've double counted those 8 people that are in both of those categories. So what I'd rather do is use these subcategories here. Instead of adding 20 and 58, I'll add those 3 red numbers up, because then I won't double count the 8. Okay? So I'm taking all the people and subtracting out those 3 subgroups, 12 plus 8 plus 50. Okay? And then let's see, that's going to be 20 and 50 is 70. So I've got 120 minus 70, which means there's 50 people out in this category. Okay? So I'm just highlighting that. Now I've got all of my categories figured out, and it should make it a lot easier to answer any probability questions that are coming my way. So if a surveyed student is picked at random, find the probability that the student is one of these things. Okay, now it's going to be favorable out of total. All of these totals are going to be 120, so it's going to be something out of 120 for all 3 parts here. Okay, all right, so let's see, left-handed or blue-eyed. So it's tempting to add up to say it's 78 if you add up these, but add these numbers up so that you don't double count those 8 people. Okay, so I'm going to take 12 plus 8 plus 50. So that's, let's see, 20 plus 50 is 70, and that's going to reduce to 7/12. Okay, and now left-handed and blue-eyed, that we want to choose a student that is in both of those categories. In other words, that's just the crossover people. So my favorable people are 8 out of the 120. Okay, and that 8 actually goes into both of these numbers, so this will reduce to 1/15 if you divide the top and bottom by 8. Okay, the last question, part C, is the trickiest one, I think. So we want right-handed people or people that are not blue-eyed. Let's assume there's only left-handed people and right-handed people, no ambidextrous people here, okay? So we've got our left-handed people, everyone else, let's assume they're right-handed, okay? So I think what I'm going to do here is start highlighting the favorable. So when we're talking about right-handed, it's everyone not in this group, right? So that would mean these people would be favorable for right-handed. Okay, so Those are both going to be right-handed people. Okay, and then the other part is not blue-eyed. Well, here's my blue-eyed group, so everyone outside of that group is going to be not blue-eyed. So those people have blue eyes, but I've already got them circled, right? And then these people would have blue eyes too, because blue eyes group, they're outside of the blue eyes group. So, sorry, this is not blue eyes here. So this would also be not blue-eyed. Okay, and then so the ones that I just circled in green, those are the favorable groups for this last one. Those are people that do not have blue eyes or are right-handed. And I don't want to double count those ones either, so I'm just going to take 12 plus 50 plus 50. That puts me at 112 over 120. Which is going to reduce to 14/15. Okay, all right. Next problem, when two number cubes are rolled, find the probability that the sum is 5. Okay, so I'm going to use my favorable over my total for the probability. We've got two number cubes, so that's just two 6-sided dice. So for the total, I think, well, how many things can happen on the first number cube? 6 can. 1, 2, 3, 4, 5, or 6. Same thing on the second one. So that means we've got a total of 36 possible outcomes. All right? And now let's figure out the number of favorable outcomes. So I'm thinking, okay, here's my first number cube and my second number cube. I'm just going to make a little chart. Well, if you roll a 1 and a 4, then you got a sum of 5, right? That's a favorable outcome. You could also switch that because you could roll a 4 on the first number cube and a 1 on the second one. That's actually a different outcome, okay? And then 2 and 3 or 3 and 2. And that's it, right? You can't use a 5 because you can't roll a 0. You can't use a 6 because you can't roll a -1. So it's just those 4 favorable outcomes out of the 36 possible ones, and then that would reduce to 1/9. Because you can divide by 4. Okay? All right. Got a standard, sorry, that might have been off screen there. Got a standard 52 card deck, and we're going to find the probability of drawing a jack and then drawing a king without replacement. So that means when we pull the jack out of the deck, it's going to stay out of the deck. We're not putting it back in. Okay? So you got to know something about a deck of cards. There's 4 jacks in a deck, and there's 52 total cards. It tells us that there, okay? But on the second draw, we've taken a jack out of the deck, so that means there's still going to be 4 kings in the deck, but there's only going to be 51 total cards because we've removed a card, okay? And so when you multiply together, that's going to give us 16 over 2,652. And the 4 goes into both of those numbers. If you divide by 4, you'll get 4 out of 663. Okay, all right, that's the end of the warm-up, and we'll see you next time.